We have 12 straight up noon showing on the clock, and we will go ahead and start. I'd like to welcome everybody to the webinar today. The Fourth State Dairy Nutrition and Management Conference webinar continues with Dr. Robert Fourdraine, Assistant Director of Product Development at Dairy Records Management Service. He'll be discussing how a poor or a good start to lactation can have long-lasting effects on a cow's performance, which in turn translates directly to farm profitability. He will discuss how DRMS data shows that cows with a poor start to lactation have a 50% chance of repeating the same poor start in subsequent lactations. The Fourth State Dairy Nutrition and Management Conference presents the latest research on nutrition and management of dairy cattle and has expanded the conference impact on the industry with this webinar series. The conference and webinars are a collaborative effort of the University of Illinois Extension, Iowa State University Extension, University of Minnesota Extension, and the University of Wisconsin Extension. I ask that you please click on the evaluation in the chat box at the conclusion of the program. It's short, and your input helps us to improve future programs. Dr. Fourdraine brings more than 37 years of experience in the dairy industry, blending a PhD in animal science with leadership roles that span dairy information management and animal identification. He has served on the boards of the National Institute of Animal Agriculture and the Council on Dairy Cattle Breeding, chairs an ICAR working group, and contributed to the development of the U.S. National Animal Identification System, all efforts that strengthen the future of the dairy industry. As I always say, Dr. Fourdraine, the podium is yours.
All right. Thank you, Fred, and welcome everyone. Most of you probably afternoon, maybe there's a couple in the morning. So I will start my presentation here by introducing who we are, where I'm from. As Fred indicated, I'm with Dairy Record Management Systems, and DRMS is a nonprofit organization that has its roots in both North Carolina and Iowa. So we are a part of the two universities. We've been serving the dairy industry for over 65 years. We offer services in 48 states, including Puerto Rico, and even outside the US and the Czech Republic. Our focus is to deliver research-backed software, standardized data, and hands-on support. And we also work very strongly with our DHI service affiliates, universities, and allied industries to accomplish this task. And as I listed here, our mission is to deliver accurate, research-driven tools and exceptional support to help dairy professionals make faster and more informed decisions. So today, what I will be covering is a little bit of a background on transition cow management. Then I will explain what the new Fresh Cow Index, what that is and how it's used. How is this data presented as far as a consultant or a dairy producer can look at? And then what are the relationship between FCI and future performance? And then we'll talk a little bit more about interpreting FreshFocus results. So what is the transition period? The term transition refers to the period between, or the process of a cow not producing milk, either as a heifer or a dry cow, and calving and then producing milk. So the transition period, as we go back years ago, it was looked at just the 3 weeks before calving and the 3 weeks following calving. However, as we've learned more about cow physiology, that period is now expanded to 60 days prior to calving and an additional 30 days following calving. So it's a 90-day window that make up the transition cow period. So why is this very important? And as we've seen, within the first 2 days after a cow calving, the energy needs of that cow more than double. The metabolic stress that's associated with that increases energy demand can be very dramatic. How a cow handles the stress and moves through transition period will influence her production, health, and ability to become pregnant again, and the ability to remain in the herd. And we'll show you a little bit how FCI encapsulates all that. So, how can you go about analyzing transition cow problems? So one is to compare what you would expect a cow to perform after she calves versus what she's actually doing. Another area to look at is her fresh cow udder health. And then another, probably an area that you don't like to see is turnover and death rates. And then the last one is the dry period analysis, preceding calving. So what is the fresh cow index? So basically, in its simplest form, is the ratio of energy corrected first test day milk yield divided by her predicted energy corrected milk yield. In the formula, this is what it looks like, and we put it on a 100 basis. So what that means is that a cow, if the value is greater than 100, she's performing better than what we predicted or expected her to do on that first test day. On the flip side, if the value is less than 100, this cow actually underperformed. We expect that she would do better than what she actually did. So this work was developed in collaboration with Dr. Albert de Vries from the University of Florida that used DRMS data to develop the prediction model for what this cow would be producing on that first test day. So it's a very inclusive index. And the items that you see here all are included in that calculation. So we need to know the breed, the calving month, the region where the animal's calving, how many times she's milked. So we include genetic information, especially for first lactation animals, but also things about what happened to her. Was it a result of an abortion? What was the gestation length of the animal? Age at calving. For a first lactation animal, we don't have her prior performance, so we use part of her dams performance. While for an older lactation animal, we can use her previous lactation information. So there's a lot of variables, a total of 25 that go into this prediction of that first test day energy corrected milk. The key here is that we calculate this if the first test day occurred between 5 and 40 days in milk. If they don't have a regular test day, that happens within about a 35-day period, there may be some animals that will not get a value calculated. So what makes this measurement different than some of the others that you might have heard about? It includes data from all US regions. It also included an awful lot of data. The model was built on 1 million first lactation records and 2 million older lactation records to establish that predicted energy corrected milk. It works for both first and older lactation cows. I mean, there's been some other indexes, but you would never get a value on first lactation animals. This one does. So FCI includes, like I said, genetic data, production, reproduction, and calving information. So there's a lot of variables that go into that calculation. And then for farms that, are paid on components, there's an energy corrected milk, but we know there's farms out there that do not do milk testing for components. So we do have a milk only version as well. So let's talk a little bit about the relationship between FCI and lactation production, and we'll look at some other factors as well. So the graph you're looking at here on the x-axis, we have FCI broken out in 10 increment categories. So we start with animals that on that first lactation or second or older lactation had a value that was less than 70. While on the very right side, we have the animals that overperformed and had a value that was greater than 130. So on the y-axis, what you're seeing here is the 305-day energy corrected milk for that completed lactation. So this is not an estimate on that first test. It's actually what these animals performed throughout that whole lactation. So what you can see here is that those first lactation animals, the ones that had a poor start, they ended up for the rest of that lactation performing a lot lower than some of the other animals that had a good start. It does tend to level off once you get animals performing at that 110% or higher from expectation. And same picture here with the second and older lactation animals. There's a steady an increase in overall lactation production all the way to about 110, and then it levels off. So uh, question you may have, what about culling rates? So we typically talk about this, 60-day culling rate, but what we found is that a lot of these animals that start out with a poor transition, they may not get culled right away. It may be further down the lactation. So what this graph is actually showing you involuntary culling, so not sales for dairy or the animal's going to be milked somewhere else, but these are animals that they were sold or died, and they were not producing anymore after that. So those animals with the FCIs less than 70, you can see on first lactation animals, almost 32, 33% never started a second lactation. On the older lactation animals, that's almost 50%. So as the animals have a better transition, you can also see that a lower percentage of animals end up being removed from that herd throughout the lactation. And same picture with the older lactation animals, only more animals are leaving the herd. But there's quite a bit of a difference with those cows that are less than 80 FCI versus those above. Some questions that we've had, how does this relate to health events? So what we looked at was health events that take place in the first 40 days in milk versus those that take place after 40 days in milk. Do cows with low FCI have more cases of health events afterwards? Or what about, in the beginning of lactation? So what you see in this little table here again is the breakdown on the left side of FCI values, less than 70 all the way up to 130 or greater. And then the percentage of animals that had mastitis less than 40 days in milk for first lactation, second and greater, and then other issues that we reported like ketosis, milk fever, DAs, retained placenta, metritis. So what you see here is that, there's quite a bit of an increase of those events reported or recorded on these animals that had a poor start. While, the midpoint there, animals in the gray area here between that 90 and 109, you can see, the typical values you see. In some cases, they go down, but, especially those animals with a poor transition, those numbers go up pretty drastically. So as the red arrows indicate, if you have animals below 80 FCI, you do tend to see a couple more cases of mastitis, and definitely you see more metabolic disease issues on those animals that are scoring less than 90. So what about after you get past that 40 days in milk? What you can see here is similar analysis. Only in this case, we're seeing a slight uptick in mastitis cases for those animals that are doing really well in their transition. I don't know if this is statistically significant. We have not looked at that, but you see there's a little bit of a trend. While on older lactation cows, that there's not a huge difference, and same with other disease issues that were recorded. Now, one question that people have is, so if my cow performed poorly in her first lactation or second lactation, what's the likelihood she's going to do this again? Is it just a one-off and I fix the cow and she'll be good the next lactation, or do we see a repeat? So what this graph is actually showing, again on the x-axis broken out by FCI category, from cows going from their first to second lactation, um, what percentage of animals performed below expectations. So the blue bars are animals that in their next lactation performed with an FCI less than 95, so below. The orange bar is the ones that did okay, 95 to 105, and the green bar, animals that actually did better. So what this shows you right now here is that, those animals that had a really poor start to their first lactation, 54% underperformed again in that second lactation. Now, the one thing to keep in mind here is that the second lactation prediction already included that the animal underperformed in their first lactation. So it already said, well, we expect you to be underperforming because of your history, but these animals underperformed even more than what their prediction said it was going to be. So what this shows you here is that, those animals that start out very poorly, even if they make it to the next lactation, they probably will underperform again. While on the flip side, those animals that outperformed, only 34% of those would underperform in their next lactation. Again, the same principle here. Our expectations would be higher for those animals to start out with because they did really well in that first lactation. So, but they did relatively well again in that next lactation. On the flip side, animals that did very poorly, only 26% actually ended up doing much better in that next lactation, or somewhat better. So re-emphasizing that, what happened in that first lactation carries with you, and there's a lot lower chance they're going to do better in that next lactation. While those animals that did really well, there's a 46% chance that they will do really well again in that next lactation. So this is going from first to second. Looking at older parities, similar picture, only the numbers are a little bit higher. So a second lactation cow going to a third lactation, 55% of those that did poorly will do poorly again, while on the other side, only 30% of those that did very poorly will actually do better than expected. Animals that did really well, or didn't do so well, only 27% will do better in that next lactation, while 50% of those that did really well in that second lactation will do even better or as well in their third lactation. So this again shows you graphically how a poor start or a good start carries with you into that next lactation. So summarizing what we learned from the data, we looked at about 1.5 million cows grouped by those 10 FCI increments, starting as low as 70 or below up to over 130. The culling rates decreased from about 33% to a little bit over 18. Peak milk yield, even though I did not show you a graph, they're significantly higher, over 20 pounds higher on those cows that did really well. Overall lactation performance, 6,000 pounds better. And then the overall disease goes down from about 10.2 to 3.4. And as far as repeatability, if a cow had a value of FCI that was less than 90, you had a 50+% chance that she will do poorly again in that next lactation. On the second lactation or second and greater lactation, the numbers point the same way, only they're a little bit bigger. Culling rates, they were like almost 49% for those that underperformed, while those that did well, it's only 33. Peak milk yield, almost 40-pound difference, while overall production from 24 to 32, so almost 8,000 pound better overall lactation performance. Then the disease, lower incidence rates, and the repeatability, the same thing. An animal with a poor start, if they made it to that next lactation, there's a 50% chance they would have a poor start again. So this is what the numbers kind of looking at how FCI relates to future performance looks like. So what can a dairy producer or consultant look at? So these, what I'm going to present to you now are some graphs and tables that you can find online that you can use to analyze an actual herd's information. So this graph basically shows you the FCI based on energy corrected milk by month of calving. So each bar presents those cows that calved in that particular month. The width of the bar is from the bottom part here, the 25th percentile, up to the 75th percentile. So it's a distribution of animals. So the way to look at this is the wider the bar, the more variation you have between your animals. The narrower the bar, like this one here, the animals are far more consistent than the animals here with the wider bar or longer bar. The median is the black line. That's your 50th percentile. And then the other thing to look at is that red line that goes through it. If animals perform as expected, the number would be 100. So if the bar is above 100 or predominantly above 100, that tells you cows in general are performing better or as good as we expected. However, if you see bars that are below, then the majority of cows are not performing as what we expected. And this is looking at it by month of calving. So there could be nutritional impacts, could be weather, environmental related. So you look at this over time and track how are these bars moving. To support these numbers, we also have, or support these graphs, you also have the actual numbers. So there's a table here that you can look at those values on each calving month. You know, how many animals calved, how many were we able to calculate an FCI value for. We look at areas such as gestation length, and this is a really interesting thing nowadays because dairy farmers are breeding so much to beef and gestation length are quite different depending on the breed of the service sire. So what we've seen also with dairy breeds is that Holsteins are calving earlier than what they did like 10, 15 years ago. So you may have animals that had a long gestation length or a short, and maybe that had some impact. So that is something we make available. Another area here is, you know, what is this difference on FCI? So, you know, this relates more to the monetary aspect of it. So if the number that you see here, so for example, in May, those animals that calved in May on average were minus 19.5 pounds ECM difference. So what that tells you is that the expectation of these animals was that they should have produced almost 20 pounds more energy corrected milk, those animals that perform below expectations. So you translate that on a single day to multiple days, that's a significant financial impact. On the flip side, you know, you'll see months where it's higher or close to it. So those, you know, you had a good month. So looking at, you know, what are those values gives you a little bit of an indication of how much there is to be gained if you can improve that transition management program. Another area that we have is the annual report. So the annual report takes all animals that calved over the past year, 365 days, breaks it down by lactation, and it shows you, you know, different measurements for all those animals. So in this case, the area that you're seeing here in red shows you the energy corrected milk gain that could be made per cow per day if those animals that were below 100 performed at being 100. So those first lactation animals, if they had calved and performed at 100%, there's a 3.4 pound milk or ECM that could be gained. On those older lactation cows, it's as much as 4 pounds. When you multiply that with all the animals that perform below expectation, the gains, now the numbers become even bigger. You're talking about 337 for first lactation and 431 pounds of milk per day. Other numbers you can look at is the distribution, and I find this one most intriguing. An average is an average, and my analogy to averages is if I put my left foot in ice cold water, it's very cold. If I put my right foot in boiling water, neither one's very comfortable, but on average, it feels fine. So, and that's why it's important to look at distributions as well. Looking at how many animals are performing below expectations versus those over gives you a little bit of an indication how much there is to be gained. So in this little table you see here, first lactation animals, 12% of those animals that calved in the past year performed below 80 FCI. So, but on the good side, we had over 50, almost 60% of the animals, the first lactation cows that did what we expected or better. So tracking this distribution tells you, how are we doing, broken out by groups of animals. Another area to look at is in the farm's herd, those animals that perform below expectations, what was their actual 305-day production? So what you can see here is not just, the averages across, 1.5 million animals. This is for the actual herd. So those cows in this herd that, if we look at the older lactation animals that were at an FCI less than 100, they produced just under 35,000 pounds for the remainder of their lactation. But those cows that did better, they were over 39,000. So there's almost a 4,500 pound difference between those animals that started out really well. The number of animals less than 100, you can see how many there are, and also the departure rates here, culling rates. So in this herd, again, those animals that were less than 100, those older lactation cows, almost 24% left versus the cows that did really well, just under 13% left in that lactation. So these are the actual numbers from the herds themselves. If you want to look at individual animals, you can look at a scatter plot. So each dot represents an actual cow. And the way you can look at this, if you want to look at outliers, you can look up who that cow is and find out the reason, but also you can look at the trend. So what you see in this graph here is that, the dots were pretty much scattered around that red line, which is that 100. If the cows did what we expected them to do, they'd be close to that 100 line. So we can see, in 2025, there were cows above, some below, but then as you get further into 2025, you start seeing more of those animals below the red line. So there was a trend that these cows were not transitioning as well as what they were before August of 2025. As far as looking at individual animals, you can look at, there's ways to look at each individual animal, what their FCI is, what you could gain if that animal was 100, or for animals that are over 100, how much more pounds of milk are you getting out of those animals? Here's some additional information, their components, their cell count, so you can look at some of these poor performance and see if there's any particular reason why. So I'll switch here. Before I start going into some actual herd examples, are there any questions?
Dr. Fourdraine, I'm not seeing anything in the chat box. If somebody wants to go ahead and unmute and ask the question, they're very welcome to do that.
Yes,
Not here.
I use this moment to drink a little bit of water here, so I'm ready to go on.
Okay.
All right. Well, thanks everyone. And again, if you have questions, feel free to put them in the chat, and we'll have some time at the end to talk a little bit more about some of the information. So we've talked a little about in general the information that's available, the bigger impact across herds. So now what I want to show you is a comparison between two herds utilizing the summaries that are available through FreshFocus. So the first one we talked about is the trends by calving month. So you see two herds here. The first herd in the top left corner, you can see on there, these are third and greater lactation cows. The bars are narrow and they're pretty much above 100 up till more recently when they started kind of sliding down. It wasn't like an immediate drop, but you could see by calving month that the numbers started dropping down a little bit. So, but they've traditionally done really well with their transition cow program. The herd at the bottom is a little bit different. So they've actually done about the opposite of the herd at the top. They've consistently been, below expectation, but then more recently they've actually started improving, and you can see that their FCI values have come up, and now the median is right at about 100. So the distribution's got as many cows above 100 as below. Looking at some other things we talked earlier in this presentation about cows leaving less than 60 days in milk. So what you're seeing here is a graph that shows you by month of calving what percentage of cows left less than 60 days in milk. The blue bar are your first lactation animals. The orange bar are your second lactation, and the yellow bar are your third and greater. So again, the herd on the top left was herd number one. The one on the right bottom is herd number two. And you can see here that the culling rates for herd number one are definitely higher. You're looking at 20, almost 25% at certain months of those animals left less than 60 days in milk. While herd number two, those numbers were quite a bit less. They were, at maximum about, 10%. So when you looked specifically at died, which is a subset, uh, again, herd number one, you can see that death rates were quite a bit higher, but they've come down over the past year. So, they were running, 10, 15%. And then, since early 2025, those numbers have actually started coming down. While number two herd, those numbers have pretty much stayed very low. Older lactation cows 4%, first lactation cows even less than 1. So not a lot of animals died less than 60 days in milk. So yeah. Now we talked about dry period analysis. So here's the dry cow cure rates. Now remember how herd number one was doing really well with FCI and it started slipping. So here you can see the dry cow cure rates. So they used to be, 90% or higher, and they've kind of slipped over time, and now they're down to about 80%. So, they're still in typically a good area, but they were a lot higher. Now, on the flip side, herd number two, they were running, as low as 72 to about 76, and their cure rates have improved over time. So you can see that, again, FCI value started coming up as well, and, the dry cow cure rates have come up as well. Looking at dry period length, so these graphs can look a little overwhelming, but there's two lines and then the bars. So the bars are your average days dry for your second lactation, and that's the blue bar. The orange bar is the average days dry for your third and greater. So on this first herd, they tended to start going up a little bit. Now they've come down again. And while your lines are basically the percentage of animals with a dry period between that 4 and 70 days of dry period length. So again, numbers were really good. They've slipped a little bit, but still very good at 97%. On the second herd, those numbers are definitely a little bit lower. The 93% of the herds have, that 40 to 70 day dry period. On your older lactation, your second lactation, about 92. It used to be better. It's come down a little bit, while your average days dry has gone up slightly on those older lactation cows. Another area to look at is that transition from that prior lactation to your next lactation. So you can look at fresh cow cure rates. So here's a little summary again of those two herds. Herd one, had an excellent dry cow management program, and those animals that calved and came back, 88% of those animals were clean. While on the second herd, it was 71, so a little bit less. As far as not cured, both of them are pretty low, newly infected, and you can see on the second herd, there's a little bit more animals. So this is another analysis you can look at over time. How are these cows, how effective is my dry cow period as far as managing somatic cell count? Here's a graph over time. So not only can you look at it, what it looks like today, but you can also track this number over time. So herd number one, that percentage of clean animals has always been very high and still is. On number two, you can see there's still some room for improvement there. It's definitely has improved, but there's still areas of improvement to be made. In terms of overall udder health on first test day, so this graph probably looks familiar because it's built the same way as the FCI graph. Looking at it by calving month, you can see the distribution of first test day somatic cell count. So the same concept here, a narrower bar is better than a wider bar, and a linear score of 3, which is 100,000 cell count. You like to see, the majority of these cows to be below that red bar. So you can see in herd one, with the exception of a couple of months, the distribution was well below that linear score of 3, while on the second herd, you can see there was a percentage of animals that did end up with a higher somatic cell count on that first test day. So there's definitely, in that area of mastitis and management on the second herd, there's improvements that can be made. So now we get to this annual report comparison. This gets back to what's the gain? How can we convince a dairy farm that by making these management changes, being it the dry cow period, being it facilities or things like that, what's the gain that could be made? So here's herd one and herd two. They're equal size. They're about you can see the number of animals that calved around 800 to 1,000. And on most of these animals, we are getting an FCI value. So you can see on the first herd, almost 90% of the first lactation cows, we were able to calculate an FCI, and their predicted energy corrected milk was 86.5 pounds. On the second herd, first lactation animals, about 83.6. So, the numbers on herd one are actually a little bit higher, but they're both in a similar range. However, when you look at the FCI values, they're quite different. And one of the questions I've had at meetings said, well, if a herd is a really high producing herd, aren't those FCI values by default higher? And that's not true. So animals that have by their history or their genetics an expectation that they should be higher producers, the expectation of that energy corrected milk will be higher. So if they don't perform higher, then the FCI values will be below 100. So, and the first herd, you can see here, the average FCI value for every lactation group was above 100. So on an average basis, the herd was doing really well. While on the second herd, those numbers were below, especially on those first lactation cows. There's quite a bit of room to improve on those animals. So what is the improvement that can be made? So even though on herd one, we're on average doing really well, what about those cows that are still underperforming? What if we can make those animals perform as expected or better? There's still on those first lactation animals 5.7 pounds of ECM that can be gained. And those older lactation animals 4.4, while on the second herd, the gains are bigger. So there's 11 pounds to be gained on those first lactation animals, while on those older lactation cows, it's over 12 pounds of milk that can be gained. So when you multiply that times the number of animals, oops, one step back, you can see, 1,900 pounds on those herd number one first lactation, while on the second herd, there's almost 8,700 pounds that could be gained based on all the number of animals that perform below expectations. So you multiply that times the milk price, there's a significant amount of money that could be gained. So the question then is, if those are potential gains, what's the investment to make this happen? I mentioned the distribution. I find is one of the most powerful things to look at. Will every animal perform as expected? The answer is no. But, how many can you move from this lower category into a higher category? Not every animal is going to be 120%. So, and they don't have to be, but can I make these animals that are less than 80 move up into the higher categories? So herd one, you can see, even though on average they're doing really well, there's still 13% of these first lactation animals that underperformed. So there's still a number of animals that can improve. Obviously, on the second herd, that percentage is quite a bit higher. There's a lot of animals that just did not perform as expected. So where can I find this information? And this is kind of my concluding slide. This information is available through DRMS, the Herd HQ which is our suite of web decision tools. Any dairy farm that sends their data through DRMS, if they participate with CDCB and get genetic information, you can find information about FreshFocus in the different products. So as long as you go to an internet browser, you're able to access your data. If a herd uses Dart and signs up on Dart Sync, you can actually see all your data as of today and look at individual cows, etc. So the programs that are there are Cow Compass, that's an individual cow lookup. Dairy Depot is where all the FreshFocus summaries are at that I showed you. And then there's several other products that you can use to look up data on your animals. And there is no extra charge for a dairy farm to look up their data in Herd HQ. So Fred, that's what I have and available to answer any questions.
Well, thank you very much, Dr. Fourdraine. We do have a question from Karen. Ask, is there a minimum herd size that this can be used on? If the herd size is less than 150, are there truly enough animals to effectively use FCI? And then follow up, what is the additional cost?
Sure. So the first one's a really good question. When a herd is below 100 cows, instead of looking at just a single month of animals that calved, it actually looks at 3 months. So it's basically building a trend by combining 3 months worth of animals that calved. A mid-size herd, it's 2 months. A larger herd, it's a single month. So by bringing some more of those animals together into those graphs, it does take some of the variability out of it. So yes, it will work for smaller herds as well. As far as cost, like I mentioned, there's the DHI testing, that's part of it. That's kind of out of our hands. But if you have your test day information, as I mentioned, you can go online and dairy farmers don't have to pay for this. If they process their records with DRMS, they can go online with their user ID and password, and all this information is accessible to them. It's included in their processing fee.
You mentioned that on the smaller herd, it goes as much as 3 months. So if I'm thinking here in my part of the world, that can go from really nice spring weather to
Mhm.
miserable hot, high humidity. Does that affect that?
Yeah, and I mean, you depending on the farm, the environmental factors and all that, you can see seasonality on some of these herds. I mean, some herds you see very little, while other herds you see quite a bit. So, this graph that I showed you, you can look at it over 2 years. So if you see a general trend that repeats itself from year to year, maybe it's just a function of, the weather or the facilities and, how the cows are managed. But, there's that aspect, but the ones I typically look at are those changes that are not, tied to anything. Maybe it was a feed change, and I worked with a herd that actually, the numbers look really nice. I mean, the herd was producing over 30,000 pounds of milk, and he said, "There's nothing wrong." Well, the nutritionist made a ration change, and it wasn't immediately noticed by the farm that things were not going well. So I looked at this, and those FCI values started dropping very soon after the ration change was made. And you could tell that, animals were being impacted by, the changes pretty rapidly. It took the farm a month to figure it all out. That was the cause, and then they rectified, and you could start seeing the FCI values going up again. So it does show, changes in management and how that can impact those numbers.
Very good. Payout to ask us, since the expected performance and genetics are figured in the calculation, is it expected that low FCIs are mostly attributed to transition cow management, such as environment, mastitis treatment, and feed program?
Yeah, so like I mentioned, there's 25 variables that go into it. Genetics is one, but probably genetics weigh more heavily on those first lactation animals than they are on the older lactation animals, because you actually have actual data on that animal from a prior lactation. How sensitive is it to certain changes? And that gets into the model. Like I mentioned, seasonality is included, the location in this country. Obviously, nutrition is not a factor that's included in it. It's based on production, but as nutrition changes, if production changes, that will impact those FCI values. One additional on the genetic side. One of the questions I got recently was, well, if I have a herd with extremely high genetics, my FCI values just will be very good. And that doesn't have to be true. You can have a herd with tremendous genetics, where the expectations then will be higher as well. So if the herd doesn't meet those expectations, those FCI values can still be lower than 100. While a herd that has lower genetics, but does a really good job managing those animals, you could see FCI values over 100. So genetics is not, correlated with high genetics translates to high FCI values. So it can be quite different.
Early on in your presentation, you talked about health events and specifically mentioned mastitis treatments. But does that also include instances of high cell count that aren't actually treated?
So, there are different ways to look at it. When I did that comparison, I looked at reported health events. I did not look at treatments.
Yeah,
So it's like if a cow was recorded as having had mastitis, basically that was yes, check mark. She was included in that count.
very good. As folks have questions, they can either type them in or I'll pause for a few seconds, unmute, and you can ask the questions directly. Going back to the health events, my question is, does this include lameness or when a hoof trimmer comes in and does hoof repair?
That one was not included. Lameness was not part of it. I mean, we certainly collect it, so we could take a look at it, but I did not include that in uh, those two tables that you saw.
Okay. Okay, the last question that came in during the presentation. Are there breed or crossbred adjustments? It seems we have a lot of crossbreds out there. Is there
Yes,
adjustments?
yes. There's the Holstein factors, the Jersey factors, and then there are uh, mixed breeds, XX or XD, whatever you want to call it, factors. So there are adjustments for different breeds. So
Excellent. Okay, we'll pause for just a second. I'm not seeing any additional questions come in. I'd like to thank you, Dr. Fourdraine, for sharing this information and your insights using DRMS tools. I'll remind everybody that this program has been recorded and will be available on the Fourth State Extension Dairy Group website in 2 to 3 working days. In addition, I will email you when it's available, and I will include the link to the program evaluation. Only 5 questions. Please take 2 minutes and answer the questions in the evaluation. This helps us improve this webinar series. Thank you for your participation, and I look forward to seeing you at the next webinar next month. Thank you, Dr. Fourdraine.
thank you, Fred. Have a
At
good
the
afternoon, everyone.
At this point, I will conclude today's program.